Hey guys, welcome to question FM 304 of the Further Maths Fortify Study Guide. This question reads, the perimeter of a regular hexagon is 240 centimeters. The area of the hexagon in square centimeters is closest to what? So in order to set up this question, now we're not given the formula for the area of a hexagon in Further Maths, so what we're going to do is divide it down into 6 triangles, and if we can find the area of one of those triangles and then multiply it by 6, we should have the area of our hexagon. So those triangles are going to look like this. So those triangles are all similar. In fact, they're all the same exact triangle. So from here, some clues that can start helping us in order to helping us find the area of this triangle, because of course in order to find the area of a triangle, there's a couple of different formulas that we can use. However, the one that's probably going to be easiest for us to use is half times b times c times sine theta, where b and c are the side lengths here, and theta is the angle here. So we'll use this triangle here as our example triangle. So from here, one of the first things that we can figure out is this base length along here. So we've been told that all up, the perimeter of this hexagon is 240. So we could say that the base of one of the triangles is going to equal that 240 divided by 6, because we've made up of 6 bases to make up the perimeter, which tells us that one of these base lengths, so this length here, is going to be 40 centimeters. So you can whack that into a calculator and you'll get that answer there. The next thing that's going to be helpful for us to figure out is also the angle. Now I'm finding these out given that we've got angles and we've got some side lengths in here. So the angle that we're going to be working with, now of course all the angles together in the center here are going to total to 360 because they make a full revolution. So we can take our 360, and since there are 6 triangles, and there are 6 corners of a triangle making up that circle, we can divide that by 6 to tell us that we've got an angle there of 60 degrees. So we've got a length here of 40 centimeters and an angle of 60 degrees. Now, seeing that one of these corners is 60 degrees should also tell you that this is going to be an equilateral triangle. So if this corner here is 60, that means that there's 120 left to be evenly spread between the next 2 corners. And that is going to mean that all of the angles in here are actually 60 degrees, which also tells us that these 2 side lengths are also 40 centimeters. So all the side lengths and the angles are the same. It's an equilateral triangle. So going back to our area of a triangle formula, we can now say this is half times 40 times 40 times sine of 60 degrees. And this will give us the area of one of our triangles, which should be roughly 692.820 so on centimeters squared. And finally, to get the area of our hexagon. Now, I wouldn't clear this or use this number exactly. I just use whatever popped up into the calculator. I just put in times 6 for this, but obviously the way I'm writing it out here is going to look a little different because we're trying to explain what's happening here. But we've got 6 times 692.820. Obviously putting in the exact value that you got from your calculation before, or just putting 6 times in front of this little formula here, should give you the exact 4156.922. Again, these decimals go on, centimeters squared, which is most similar to option C. If you guys have any questions about this question, please drop them in the comments below. Otherwise, I will see you in the next video.